tack that on somewhere at the end or wherever. Shoot, it didn't charge. I'm in poo-poo. Hey, I always spell that wrong, so don't give her a hard time. This should be another section. Tack it on here. Okay, so what we're going to be doing today dealing with indicators and acids and bases. We won't combine an acid and base, but if we were to do that, so first of all, let's title this Energy Involved in Chemical Reactions. Okay, so we're going to be using this today for sure, HCl. Okay. Now, let's say you combined it with one of the bases we're going to be using. We're going to use, well, we're not going to use, but let's say we did use it. We're going to write down NaOH. Sorry here. Actually, you know what? Sorry for this. It's confusing you, but we are going to be using this. We are going to use that base, aluminum hydroxide. I picked that up for you last night. Okay? Whenever you have an acid and a base react with each other, this is an acid because it starts with an H. This is a base because it ends with OH. You always end up with one H combining with an OH to give water. This is just a quick way of writing H2O. Or a different way of writing H2O. Helpful way. You'll see in a second because we're going to balance this. What's left over is, yeah, just find a seat, is the chlorine and the aluminum. And that's going to make up aluminum chloride, which we call a salt. This is called, it's not table salt. But whenever you reduce or react an acid and a base, you're left with water. And then the positive and negative ion make up a salt. Okay? Now, because you're forming water, water forms a very strong bond. And whenever you form a very strong bond, you release lots of energy. So this reaction actually, I'm going to put E at the end. Okay? No, I haven't balanced the reaction. I mean, I can balance it quickly for you, but that's not the main point. The main point is this. This water that's formed is a very strong bond, and as a result, releases energy. Whenever you have a strong bond forming, lots of energy released. Okay? So you go from high energy with the reactants. Remember, this side is the reactants. To low energy. With the products. This rectangle box is the products. Don't worry about balancing it. You can come back and do that yourself. The main point is that you end up with lower energy products. What happened to the energy? Let's say, I'm just making up these numbers, but let's say there was 100 kilojoules here, and you drop. You go from 100 to 50. What happens to that extra 50? It's released in the form of heat. That's this here. It's released in the form of heat, and sometimes it makes even a flame. Not in the case of this particular reaction, but it can in other. This is called an exothermic reaction because it releases, we talked about this, I mentioned this before, exothermic reaction, which means it expels energy. Yeah. How much time have I got here? 3 minutes. Ha, that doesn't work. Okay, so how do we indicate this on a chart? Let's take a look. Okay, so this has to do with, this is a chart of energy versus, you can think of it as progress of the reaction. Usually it's time, but we'll just be consistent with your workbook. Progress of reaction. It's related to time. Okay. So on the left side is where you're going to start. On the left side, you're going to have, indicated by a horizontal line here. That's your reactants. Represents the energy of the reactants, which in this case is 100. Let me move this over. This is all in kilojoules. Okay. And then further on, as the reaction progresses, you start getting products. Let me just make sure I put this in the right place. So this level here represents products, energy level of the products, which we said here was 50 kilojoules. So this is 50 here. Okay. So this graph represents what I said earlier about there being a drop in energy. You go from a higher 100 to a lower 50. So this difference you dropped. Okay. Total of what? 100 minus 50, which is 50 kilojoules. That's how much energy was expelled. That's this here. So the difference is called the overall energy change. Okay? I'm going to make this a little smaller. I'll put it here. Sorry about that. I need space. Okay, now one more point here. In order to get this reaction to actually happen, you need to add a little energy. You need to add a little bit of energy here. So there's a little bump that indicates that. And then it comes back down. Okay. So what's this here? This might be the 100 and let's say that's 130 kilojoules. So this difference here is 130 minus 100 or 30 kilojoules. That's called the energy to activate, the energy to get it started. We can shorten it and call it activation energy. That can simply be just whatever the energy you get from the surrounding area, the room, activation energy. The energy to activate it, to get it started. Energy to get it started. To get what started? To get the chemical reaction started. Okay, so that's enough. I was going to do more, but that at least gets you started with it. I'll have to add on to it next day. So that's an exothermic reaction. I've got to explain and give an example of an endothermic reaction next day. But what we started with was, again, a neutralization reaction. Let's just balance it quickly. Let's go back to it. You guys can check this out, see if I'm right. Put a 3 here. Put a 3 there. That should be balanced. Okay. Okay. So I'll add on to this next day. For homework tonight, yes, you got the lab, but you got the weekend to do this. It's not going to be due next Thursday. We'll get started on it today. You collect the data today. For the homework tonight, it's just going to be page, let's see here. You're going to do page 97 and 98 in the workbook. Okay, you need to actually do a little bit of reading. It says so on the top of page 97. I'll link that while you're doing the lab. I'll post that for you. Okay. And then we'll go on to endothermic next day. Okay, so you can just put everything aside. We'll get started on the lab in a minute here.